Welcome. We're now ready to take a look at comparing z-scores when data values come from two different populations. So if we have two populations that each have bell-shaped distributions, we can use z-scores to compare the relative standing of a data value from one population with the relative standing of a data value from a different population. So the idea is the larger the z-score, the larger the data value relative to the population to which it belongs. All right, so we're going to take a look at an example where we have two distributions that are bell-shaped. Just a note here, if we're given a problem and we don't know the populations are bell-shaped, so perhaps it will indicate that they are skewed, then we are not going to be able to make any meaningful interpretation of the z-scores. So we would say it's unclear how to interpret. All right, but the problems that we will be doing will be given these bell-shaped distributions, so we can move forward and compare z-scores. All right, so here we go. Number one, Hill College and Dale College are two local colleges. For each college, the distribution of ages of the faculty members is clearly bell-shaped. So there's that condition met. The ages of faculty members at Hill College have a population mean of 58 years with a standard deviation of 4.8 years. And the ages of faculty members at Dale College have a population mean of 42 years and a standard deviation of 8.1 years. All right, so I'd like to just do a little highlighting here first. So at Hill College, here, so at Hill College, the mean or the average age of faculty is 58 with a standard deviation of 4.8. And then let me switch here to Dale College. So at Dale College, the mean is lower, only 42 years compared to 58 at Hill College. And for Dale College, the standard deviation is 8.1 years. All right, so we have George, who's a 45-year-old faculty member at Hill College, and Paul is a 28-year-old faculty member at Dale College. And so the idea here is we want to think about how George compares to the faculty members he works with in terms of his age, as opposed to how Paul feels among the faculty he works with at his college. And in order to do the comparisons between these two different populations, we will find the z-scores for each of them. So what we'll do here is start with just summarizing some information. So let me start with the values for Hill College. All right, so the population mean mu, 58 years, and the population standard deviation, 4.8. And then I'm going to come over and look at Dale College. At Dale College, the population mean age was 42 years with a population standard deviation of 8.1 years. All right, and then we have George. And George is 45. So X represents a data value from the population. So there's George. And then we have Paul over here working at Dale College. And X, his age is 42. Oops, no, he's not, sorry. Paul is 28. All right, so z-scores give us information about where they fall relative to their population. So the formula, z is x minus mu divided by sigma. So George is 45. We'll subtract the mean of 58, divide that by the standard deviation of the population. So let me go to my calculator and do that first. So 45 minus 58. So negative 13 is our numerator. So that means that George here is 13 years below average. And to turn that into a z-score, we divide by sigma. So we'll divide that by 4.8. And then we're going to round to 2 decimal places for our z-score. So that's looking like negative 2.71. And we'll be putting that on a graph in a moment to sort of do a little comparing, but we'll hop over and take a look at Paul's z-score relative to his school and faculty. So I'm going to write my z-score formula again. Z is x minus mu over sigma. So Paul is 28 minus the average of 42 at Dale College, divide by 8.1 for the standard deviation. So I'm going to do my numerator first again. So in this case, negative 14 indicates that Paul, who's 28, is 14 years below the average. And then we turn that into a z-score by dividing by the standard deviation. So divide that by 8.1. And then I'll round that to 2 places again. So that's negative 1.73. Okay, so before I complete sentences, I do want to just go to the bottom and show you the visual here. So now that both of those values for George and Paul have been converted into z-scores, and because both populations were bell-shaped, we can now compare them on one distribution, so our z distribution. So 0 is in the center for z, and Paul, actually let's do George first. George came out to be negative 2.71, so we don't need this to be perfectly drawn to scale, but here's George. So George is quite far below average. So remember, the mean is always the center of any bell-shaped distribution. So George here, whose z-score was negative 2.71, as opposed to Paul. Paul was also below average at his school, but that z-score for Paul came out to be negative 1.73. All right, so both are below average at their school. And let's then fill in these sentences. All right, so George. So this is how many standard deviations he is. In this case, he's below average among his Hill College faculty coworkers. So George is, so we say a positive number here because we're going to say how far he is below. So below is indicating the distance below average. So the z-score is negative, but when we speak, we would say this many standard deviations below average. And Paul is also below average, but he is only 1.73 standard deviations below average among his colleagues. Okay, so if George goes to a conference with his colleagues and Paul goes to a conference with his colleagues, both of them are on the young side, but the faculty member with the lower z-score, so lower on that graph below, was George. George is further below average at his school in comparison to his faculty members. So relative to his school, I'm going to say that George then is younger. So we're not comparing the two people directly because George here is 45. He's definitely older than Paul. But we're saying that if we compare George to the faculty he works with, he's going to stand out as the younger member as opposed to Paul with the faculty he works with. All right, and then I'm just going to add one more bit of information here. So remember that 95% of z-scores are within 2 standard deviations of the mean. So I'm just going to draw a line here at -2 and +2. And we know that approximately 95% of data in a bell-shaped distribution is within 2 standard deviations of average. So once we start having values more extreme, more than 2 standard deviations above or below the mean, this is when we informally start to think of values as standing out as a bit unusual. So I'm going to just shade here anybody that has a z-score in one of these two, we call them tails of the distribution, is standing out as unusual. So the faculty member here who might feel unusual or atypical, just informally speaking, is going to be George, because he's so far below the mean, more than 2 standard deviations below average among the colleagues at his school. So that's going to be George again. Okay, and that is how we compare data values selected from 2 different populations that are bell-shaped, calculate their z-scores, and we'll leave this one there.